So now we will perform the second level of Hilbert fractal iteration from the slot on the right and from the left. So let us perform the second level of Hilbert iteration from the right hand side slot, this slot. Okay. So now again you imagine that the slot will be cut out from this portion like this portion. So now the X limit will not be 15, but it will be this limit, which is 10. Y limit we will change, but the X limit will not be 15 as in the previous case, as in the case of the first iteration, it will be now 10. The process is same actually. We select extrude, escape. Let us name it like this, slot right second, slot to the right in the second iteration. Orientation remains same. Z mean remains same. Height also remains same. Now we will define the points. Suppose the point here, the X coordinate is 10 because we are selecting this particular level, 10. Now this point of Y was 7.5. This point. Okay. We will select a point which is lower than that. Here, somewhere here, because the slot will look like this. Slot will look like this. So let us select 3.5. Sorry. Tab 3.5. Enter. See, this point is shown. Again, I am saying these points you can customize according to the need of the design. This is just for an example. Now the next point we will come down. Now if we come down here, X remains same because we are at the same vertical level. So X remains 10. But now Y has come to the fourth quadrant where Y is negative. So tab Y becomes negative 3.5. Enter. See, this is selected. Okay. Now we will come inward like this. If we are coming inward, then we are maintaining the same horizontal level. So Y remains fixed now. So Y will be minus 3.5 only. But X is coming inward. X is not 10 now. X is coming inward. So X will have a lesser value. Let us take X to be 7. Tab minus 3.5. Press enter. Now we are going up. We are maintaining the same vertical level. So X remains same. X remains 7 only. But now Y again comes back to the first quadrant. So Y will become positive. So positive 3.5. Okay. Positive 3.5 it will become. Again, we won't do anything with the component. We won't do anything with the material. Preview. See, it is being shown. Okay. Now, what we will do? Double click on this. Boolean. Drop down. Subtract. Slot right second. Select. Enter. The slot has been cut out. Now in this case also, previously the current was flowing along the straight edge. In the first iteration, the path length of the surface current increased by twice this horizontal length of the slot. Now it is the horizontal length because we are changing the orientation of the slot. Now the slot is along the vertical edge. So twice this horizontal separation. In the second iteration, again twice this horizontal separation. Fine. Twice this horizontal separation. Okay. So in this way, the path length for the surface current is progressively increasing in successive stages of iteration. Okay. Now the final modification is that we will cut out a similar slot on this left hand side, this slot. Okay. Now if we leave the structure like this, again we can't say that this is a fractal. Because if we are performing iterations, the same iteration level should be there on all the sides. That means on the top and the right, as the situation is now, okay, on the top and the right, we are having two levels of iteration. And on the left, we are having only one level of iteration. That is not permitted. Okay. If you are going for second order iteration, You have to go for that second order iteration throughout. Okay, throughout the structure, you have to do that. So we will be now generating the second order iteration from the slot on the left. Extrude, escape, extrude profile comes, slot, left, second. Okay. Orientation will be Z axis only. This Z min should be 1.6 only. Height should be 0.002. Same thing. Now, the X point. The X point will be somewhere here. Okay. This edge will be X is equals to minus 10. So minus 10. Y will be somewhere less than this 7.5. So let us take plus 3.5 only, similar to this slot. So since this point is in the second quadrant, Y will be positive. Tab 3.5. Enter. See, this point is shown. Now we will come down. If you are coming down, you are maintaining the same vertical level. So X will remain same. Minus 10 only. Tab. Now Y is in the third quadrant where Y is negative. So we will have minus 3.5. Enter. See, this point is selected. Now we will come inside. If we are coming inside, we are basically maintaining the same horizontal level. So Y will remain fixed. Y will remain minus 3.5 only. But X is now coming inside. X is moving closer to the origin. So X will not be minus 10. It will be somewhat having a lesser value. Magnitude wise, it will have a lesser value. So let that be minus 7. So minus 7 is somewhere here inside. Okay. I mentioned Y should be seen minus 3.5. Enter. Now this we will come up. If we are coming up, we are moving along the same vertical line. We are maintaining the same vertical level. So X will remain minus 7. But now Y has come up in the second quadrant. So Y will become positive now. So Y is positive 3.5. No need to do anything with this component. No need to do anything with this material. Review. See, the slot is visible. Okay. The slot is shown. We need to cut it out. Boolean subtraction. Double click on this patch. Boolean drop down. Subtract. Slot left second was the one which we wished to cut out. Select it. Enter. Your structure is ready. Now see, many criteria are satisfied in this final version of the structure. In this final version of the structure, the basic requirement is you should have increased the path length of the surface current. Actually, it is done. Okay. So in this third slot, which we cut out at the very last, the slot to the left, initially the path length increased by twice this horizontal dimension. You can see here and here. In the second iteration, again it increased by twice this horizontal dimension. So the same sense is basically followed in all the slots. Okay. As you keep on increasing the dimensions, as you keep on increasing the iterations of the fractal design, you are increasing the path length of the surface current in a periodic manner, not only in a random manner, in a periodic manner you are doing it. Because every time, twice the horizontal or vertical dimension of the slot, whichever fits the orientation of the slot. If the slot is oriented vertically, it is a vertical dimension, as in the case of the slot at the top, vertical. If the slot is oriented horizontally, like this, along the X direction, then it will be the horizontal, twice the horizontal dimension of the slot. So according to the orientation of the slot, according to the placement of the slot, how the path length of the surface current will increase, that depends. The second thing is that we told you that whatever shape you are starting the fractal design, you have to continue with that same shape. If you are starting with a rectangle, you have to continue in terms of a rectangle only. If you're starting with a triangle, you have to continue with a triangle only. You can't mix and match. And we have performed successfully the second level of iteration of this Hilbert fractal, and it can be observed that we have not mixed and matched the shapes. The shapes are same only. The shapes are rectangular slots only. So that requirement is also satisfied. The third requirement is that we can't make the order of iterations different in different sides of the patch, in different sections of the patch. Same thing we have maintained here. We have performed this fractal design up to the second order iteration in both the sides. I mean, in the top as well as on both the sides, the left and right. We have not mixed and matched that we have performed the second level of iteration on the top and to the right, and the first level of iteration only on the left. We have not done like that. Okay. So the basic three requirements of any fractal design is shown. So ultimately, we can conclude that this fractal design is complete and we have incorporated a second order Hilbert fractal in the initial square patch. Now I will just show you how the structure looks, because till now I have kept this substrate hidden. I have kept this substrate hidden purposely. So I will just pan it. I will just move it in a bit centrally oriented. I will select these components so that the substrate is shown to us. And I will select, I will press 0 on the keyboard so that you can actually see the perspective view. This is how the structure looks like. Now certainly, if you have developed a liking towards this way of generating different complex geometrical shapes in antennas, you can proceed further with further modifications, the third, fourth level modifications also. And I leave that as an exercise for your own practice. So this is the basic of Hilbert fractal design, second order Hilbert fractal design. And of course, if you want to generate, now till now, if you have observed that I have not varied, I have not made the dimensions of the slot different in different branches. I have maintained the same dimension of the slots. That means the first order iteration here, I will just show you the front surface once again. The first level slots, this one, this one, this one, the bigger rectangular slots, they are all of the same dimension, height and width. The second level iteration, this, again, they are all of the same dimensions. I have not changed the dimensions of them. If I would have changed the dimensions of them, I wouldn't have called it a Hilbert fractal. I would have called it a modified Hilbert fractal. That is also permitted. It is not something which is prohibited. You can do that. But the mandate is you can change the dimension, but not the design. Anywhere I have not used a different design in the next order iteration. First order iteration I have maintained a rectangle. Second order iteration I have certainly, for example, if I would have cut a triangular slot like this, see like this, after that a triangular slot, a V-shaped slot, try to imagine a V-shaped slot like this from here. What that meant? That meant the first iteration is cutting out a rectangular slot. The second order iteration is basically cutting out a triangular slot. This is not permitted. I mean, you can create the design, but you can't consider that to be a fractal design. That is important here.